Very good. Welcome all. Quick updates on Map of Science. Feel free to jump in, throw any comments or questions in the chat as you come up with them. So the biggest updates come from our group on Wednesday, which has been getting together with a good amount of energy for the past 4 weeks, I'd say 3 to 5 weeks, somewhere in there. We had a 2-hour call a couple weeks ago, just to indicate that energy is going over the 1 hour slotted time. We've been spending a lot of the time structuring the repo or talking about some fundamental sort of project needs when it comes to building an open source project. We've gotten a bunch of people write access at this point. I think we've got 7 folks with write access, so they can create their own branch because we decided to use the branch model instead of the fork model. Some folks have been kind enough to teach me how to do that, which is fantastic. So we've got some new scripts up that can help pull some data. Repo Finder and Repo Site. Repo Finder is the one that was developed by working with the UC OSPO network to identify repos that are used by an academic institution based on some keyword matching on some other fun stuff. Repo Site is based on some work done for the Open Molecular Software Foundation, where you have a repo that has a DOI in it, and you want to build the citation graph out of there and put in all those good data nuggets based on authors and institutions and contributors to the repo, that sort of thing. There is a third script under development, at least from my side, which I will try to pull up right now, called I forgot what it called it. Switching. I don't know how to switch screen share without completely turning it off. So be right. There you go. GitHub gather data, I think is what I'm calling it. Basically, what this one is doing, and I'll get this up there eventually, is first of all, John has learned how to get GPD to give him modular software. So it's not one giant script. It is now little modules that can eventually turn into an application. And I think this is an older version. Just my panic, I pulled up an old version. There we go. This is trying to determine the uniqueness of a repository. So I'm running it on the PyViz ecosystem right now. And the thinking here has to do with impact metrics, because the idea is if a project is incredibly unique and fundamental to other projects, something like NumPy or Pandas, it probably should have a higher impact score than one of the many interchangeable PyViz tools that are just Python visualization tools that generally do something very similar. And if you're using one and there's a security risk that comes up with that one, you can very easily, well, relatively easily switch to another tool, make a couple tweaks and start using that one instead. So this uses some interesting stuff I won't get into to look at the README files, the code, features and functions, stuff like that, to determine whether or not software is unique. And it works, not great, but it works well enough that it identifies that, hey, Pandas is kind of unique. And one of the bottom tier sort of unused or used less PyViz tools is interchangeable with a bunch of other PyViz tools. So it's working decently well, or well enough to sort of upload it and start iterating on it in the PyViz ecosystem. So that one's a lot of fun. Other stuff we've been working on in the group, we've been talking about database management and data management. And we have come away with the idea, I'm trying to get back to share screen here, that we should be, I think this is the right one, using the AuraDB instance that Alexi set up for us in the first place. So that's kind of the idea. that we're going with right now, where everything we've decided on is very much understood to be likely to change in the coming months and years as this thing builds up. But we want to port stuff into the AuraDB instance so we can start sharing data easily. We're also starting to pull data into Parquet files just to make them a little easier to share. So we're moving beyond continuously running the script every time we want to do some analysis. We're starting some data storage systems going. With these discussions, we've talked about a bunch more, but from these discussions, built out a overview, architecture, schema, and the two pipeline prototypes are repo finder and repo site, just written descriptions of them to help folks kind of understand what we're trying to build. This is very much a first iteration, first pass. It's me feeding our conversations and curating those conversations with bullet points of text, passing it into GPT to give us the text. But I've done one quick pass on it. It looks pretty good. Yeah. So I think I'll stop there. Here's our schema. This is all, by the way, in this shared drive. If you don't have access to the shared drive, you should. Feel free to ask for it. I just put the link in the chat. And you'll have access to all the good bits that we come away with from those Wednesday calls. So those are the big updates. There's probably a bunch of stuff I forgot, but that's where we're at. Any thoughts, questions, suggestions, recommendations, conferences we should go to, things like that? Very good. Then with that, I'll stop screen share. Remind everyone you are invited to join us on those Wednesday calls. You just got to ping me on Slack and I'll get that invite to you. It's every Wednesday, meet for about an hour. It's a good production call. And with that, I'll pass it. Oh, Mark, I see you joined. Do you want to add anything to the quick update of Moss over the past month?
Yeah, sorry I'm joining late. All sounding good. I think that we're building momentum and getting on the same page as far as development. We're getting the places that we want to do the development decided on as well. And so, yeah, doing well.
So, all right, with that, we'll pass it over to Dave with the software gardening almanac. Yes, nailed it.
Thanks, John. I'm going to share my screen. Okay, is everybody able to see my slides okay?
Yep. Coming
awesome.
through.
Cool. Yeah, so I'm here to talk about the software gardening almanac. Thanks, John, for the invite to present this all to everybody here, and also for the chance to be involved with Moss et al. It's been a really fun project thus far to be involved with. So a quick agenda. I'll go through a quick introduction. I'll talk about some challenges and then talk about solutions to those things. And we'll, I promise, get a lot more specific than the agenda reveals here. So quick intro to myself. I'm Dave Bunten. I hold a master's in education, master's of education in educational technology. I'm currently a research software engineer working within the software engineering team within the Department of Biomedical Informatics within the School of Medicine at the University of Colorado Anschutz Medical Campus. Currently, I'm a Better Scientific Software Fellow for 2024, finishing up my fellowship for which this project relates to. But I also want to call out that this is a collaborative effort that I'm working with a bunch of other people, namely Gregory P. Way and Will Davidson are two of the core developers also working on this project with me. So we have a big problem. So I have highlighted here a few quotes from a number of different reports. The first one up here, I'll just kind of read it. Concerns are growing about the productivity of developers and users of scientific software, its sustainability, and the trustworthiness of the results that it produces. And then down here, the national annual costs in the United States of inadequate infrastructure for software testing is estimated to range from 22.2 to $59.5 billion. That's a report that came out in 2002. So think of these things in terms of adjusted dollars as well. And then up here we have another report that cites that the cost of poor software quality was estimated to be around $2.4 trillion in 2022, which is just a mind-bogglingly big number. Like it's hard to even quantify that really next to like annual dollars necessarily. So thinking about those problems, I think it's important to think about like why scientific software at all. And kind of understand how software has become an essential part of modern science, impacting discoveries, policy, and technological development. It's from that same report that I cited before on the other slide there. In the biomedical arena, biomedical software has become a critical component of nearly all biomedical research. So pretty much biomedical research isn't happening without software at this point, as per this citation. And then another resource cites that most scholarly research relies on the same key resource, software. This comes from the US RSE Association and the IEEE Society. There was a survey that was performed through Stanford that they surveyed their school, and they found that when they asked how important is research software to your work, they found that a lot of folks were citing that it was vital. So pretty much across the board, more and more scientific software is just becoming crucial to performing any type of research that we might want to get done, and really science in general. So how much scientific software are we really talking about when we talk about these things? I think it's important to talk about like how much that there actually is, given the problems that I mentioned before. So the GitHub Octaverse report for 2024 cited that there are 1.5 million repositories on GitHub created in 2024 that contained at least one Jupyter notebook. And I'm kind of making a leap here to think of those repos as being at least somewhat scientifically related, because Jupyter notebooks have become such a core aspect of scientific software development. When looking at Zenodo, I did a search the other day myself just for software records on Zenodo, and I came across 152,888 results, which is quite a bit of software. Maybe not quite so big as the number of 1.5 million, but still we can think of those things as a little bit more specific to the scientific software arena because they're coming from Zenodo and following sort of the scholarly research paths there. And then down here we have around 8,174 unique open source repositories with connections to Department of Energy national laboratories were discovered as part of research that was performed by Sam Schwartz in 2024. So there's quite a bit of scientific software out there. I don't know that we know how big all of scientific software is, but perhaps that's something that we can help address through MOS specifically. In terms of scaling challenges, given the size of that software, so how could we resolve $59.5 billion per year in research software needs within the US, given that the median software engineering salaries are about $162,000 per year? I did an estimation here that we'd need around 367,283 software engineers each year to resolve these existing software challenges. And notably, in 2023, there were estimated to be around 10,000 research software engineers globally. That's not just the US, that's global. So probably that number has changed, but even if it has, it's nowhere close to, say, 367,000. So I think it's important to keep those things in mind when we think about some of these challenges and the scale and what we're up against and how vital scientific software really is. So how do we cultivate outsized research software impact when we think about these numbers? There are orders of magnitude differences when it comes to productivity between software developers. We know that certain developers are more productive than others. But when we studied this, the reasons for that outsized impact is different across the board. So sometimes it has to do with education, sometimes it has to do with experience, sometimes it has to do with domain specialty, but it tends to change from place to place and depending on the person to person. Um, it's worth noting that undergraduate and graduate programs may produce a better prepared workforce for addressing some of these things in research software engineering in the future. There is some work that's going into building programs that can help prepare people to address these things in perhaps more productive manners, but they're not yet here today. So really, I wonder what we would have to do, what things we would have to measure in order to sort of think about these things. How do we solve these things right now, and how do we start to address them in the future? And then I added this quote down here below from W. Edwards Deming, without data, you're just another person with an opinion. And I think in software, especially, there's a ton of opinion. There's been a lot written about some of these things, but not all the time do we really know what measurements to make about things. Or if we do, we haven't made them continually, or maybe in the open. Um, I think it's also worth noting that existing measures don't really show the full picture. So GitHub stars are sometimes used to estimate, say, software impact or how a certain piece of software is doing, but they're sometimes fake and might be associated with bots or scams. There was a preprint that was put out in 2024 that cited how some of this is happening, and it's really kind of scary, actually. I mean, when you start to think about GitHub stars and how prolific they've become, and sort of the climb, and I think we've all seen those repositories with those graphs that show the star chart that's going up and up and up. How many of those are really real? I think it'd be worth kind of diving into understanding that a bit better, but it's not really the full picture for software quality necessarily for addressing those problems that we mentioned. So another thing to notice here is that publication and citation metrics often suffer from diminishing returns due to increased numbers of papers more generally, larger and larger author and reference lists, and then also self-citations. This has become more and more of an issue. There's actually several reports. This is one good one that I could find, but a lot of times people are talking about how much of a problem this is. I think there's certain individuals who are publishing almost a paper per day, or maybe more than one paper per day, which kind of makes it hard to estimate what we would have to do to adjust certain citation metrics in terms of impact and understanding how that affects software. So an open question, could we measure scientific software for sustainability to mitigate costs from challenges long term? I think as part of this story that we have to think about software linters and what they mean to this wider ecosystem. So software linters, if you're unfamiliar, linters perform static analysis, e.g. Code that's not running. It's able to look at the code while it's not running to provide guidance on bug avoidance and best practices before the software is delivered. So usually these are run before software is released, and they're used to help increase the quality and help teach developers how to employ best practices and avoid certain vulnerabilities. I put a little picture of a linter up here, or a dryer linter up here, because that's what they're named after, these software linters. I think we've maybe all seen these things. They're little slots that you put into a dryer, and they help to catch little pieces of lint and hopefully prevent your dryer from catching on fire. I think we all want to prevent our software from catching on fire or making it catch fire within environments that it's employed. Historically, all software linters stem from a C debugger called lint that started sometime in around 1978 from Stephen Johnson. But maybe it was developed a little bit prior to that. I think this was the publication that was associated with, but it might have been used before that. So they've been around for quite some time. More modern iterations include, for example, Pilot, which came about in 2001, and then more recently, another linter called Rough, which has employed some of the Pilot work in addition to other linters around 2022. Rough's advantage being a lot due to the fact that it employs Rust-based work, and so it's very, very fast. So over here I have a picture of Pylint, and then rough, and then a picture of rough being used to check some code that I grabbed from the Astral docs surrounding rough. Astral is the company that helps support rough. So what you do is you just run rough check, and then it checks your code, and then you get these specific lines of feedback where in this case it's saying we have error code E501 that the line is too long, that you've that the code in that particular line was over 79 characters long. So it found one error and it's reporting that back to the user so that they'd be able to remedy that issue before the code gets deployed. So importantly, I think to note here is that linters are an educational technology. Linters provide a scalable opportunity to teach developers how to improve their code as they create their work before premature decay. So if all those issues are in the code before somebody releases it, and then somebody else has to experience that, the pains of, say, a bug or something that could have been resolved before it was released, that's far worse than, say, solving it before things get released. Creating linters often entails a community of practice also, which builds a quote unquote curriculum that can be deployed through real world classrooms. So usually linters aren't just a sole proprietor or like a sole contributor kind of a thing. There's usually multiple people who are agreeing upon certain best practices or bugs that should be avoided, and sort of builds a curriculum to teach people in real world classrooms. And by classrooms, I'm meaning like kind of where the students sit or where somebody's sitting with their code today. You can run these things, and it's certainly a whole lot less scary oftentimes than having somebody look at your code. You can have, say, just a program look at your code and give you real-time feedback so that you can resolve those things before other people have to see or experience it. Which is important to learning, and also important for that community of practice in terms of learning and sort of agreeing upon what they want to share as far as a curriculum. So I think maybe this is a typo. Perhaps 10x or 24x engineers aren't born. They're shaped by learning and empowered by a culture of teaching to mentor others. So maybe it's not so much that people are born a particular way or that they're extremely talented. I think there are extremely talented individuals, and we're all pretty darn talented, but I think we can do a whole lot to equip people with learning and help empower them with a culture of teaching to help each other. So this is where I want to introduce a topic area called software gardening. So software gardening is the practice of continual and gradual nourishment of people and code surrounding software projects. So this is very much a part of linting and that sort of educational ethos of learning to do something better and also helping other people do things better as you go. And growing that software and sort of growing a community around certain efforts. So also core to software gardening are time and software and how those two things interplay. So software undergoes changes over time, similar to a garden or a wilderness. So we all go through this process where we're developing software, and we create it, and it's bright and shiny, and it's this little sprout, and then it maybe flourishes and it becomes a full-fledged plant or maybe a garden, but then it goes through this sort of change where it becomes impacted by decay over time. Even if we don't change anything about that software, the ecosystem around that software will be impacted. The code that we write today will eventually no longer work on any system, potentially. There's probably mounds and mounds and mounds of code that no longer run on any of the architecture available for us to purchase at a store today. And it takes real work to keep that cycle going where we kind of revisit and revitalize things. There are practices which help slow decay or recycle that energy into other growth. So there are ways to take a software wilderness that we're seeing down here, which maybe has unchecked decay, competing growth, or weeds that are sort of popping up in that software garden. Or that software wilderness, and we can change that to be more of like a structured software garden that's very intentional and is structured for intentional growth. It's a protected habitat and has flexible design that might make it able to survive a bit longer. Greg Way and I wrote about this in a blog post that is linked here. And by the way, I'll share these slides after the presentation today. So I'm more than happy to share those along, and hopefully this provides some reading. I think it's also in the meeting invite as well. So as part of the software gardening efforts, we've created the Software Gardening Almanack, which is an open source handbook of applied guidance and tools for sustainable software development and maintenance. The Almanack educates developers, it analyzes software metrics, it provides open measurements that anybody can take a look at and understand, and also change. And it also empowers a culture of change for some of those software problems that we were talking about. In terms of the Almanack and how it's structured, it has two primary components. There's a book, which is primarily a doc site and PDF. So you can look at the doc site if you have access to the web and use that to browse things. But we've also published things as a PDF that you can read literally as a book. And then there's also a package, which is part of the same effort, which is used for applied discovery of patterns within repositories, i.e. software gardens. And the idea is that the package and the book are sort of intertwined, and that as you employ things through the package, that you might want to read parts of the book, and that you can learn things through the book, and then maybe reuse the package to make further discoveries where you're at with your own software. Here's a bit what the Almanack book looks like. We're using JupyterBook to help publish this, and primarily Markdown and a Jupyter notebook or a few Jupyter notebooks at this point to help demonstrate certain concepts. As far as the Almanack package, the Almanack package is installable from PyPI. You just do a pip install Almanack, and that's Almanack with a CK, mostly because the Almanack with a C was already taken by another project. The Almanack can be used in a couple of different ways as a Python package right now. You can use it through the Python API, but you can also use it through a command line interface. And the idea is here that you can take a repository that you have, and you can have the Almanack read it, and you can either get a table of metrics, or you can perform the check functionality, which performs a sort of linting on your repository for best practices. And the way that you do that is by typing out Almanack table and then give it your repo path, and then Almanack check and give it your repo path for the linting style check. And I do have an example Google Colab notebook here, which I was going to share very shortly as a quick demonstration of what we can do. As a quick note, I warmed this notebook up a little bit ago to help save some time. I'm showing the pip install Almanack, which installs the Almanack. And then I'm cloning the Almanack repo as a demonstrational set of data that we can use to have the Almanack assess basically itself. A little bit meta, but bear with me. So down here, I'm importing the Almanack, and then I'm using the Python API to get a table of metrics from the Almanack directory over here within the environment. And that's just the Git repository for the effort that we look over here. And so when I run this, and hopefully the collab environment didn't shut down on me, we get a set of metrics here. I've wrapped the output here as a pandas data frame just to make it look pretty within this environment. But we get per row, we get a measurement about the repository, including some metadata that doesn't necessarily have bearing on the sustainability or best practices for the repo, but might be informational to understand as far as a set of metrics about the repo. We have things like repo file count, repo commit time range, repo includes README, repo includes a contributing file, a code of conduct, all the way down to say more complicated or comprehensive metrics like repo ag info entropy, which is covering the aggregated Shannon's information entropy about all of the files inside of the repository. And then same thing goes for each file within the repository. When I say Shannon's information entropy applied to software, what we're doing is we're using the the line count diffs between commits to help calculate Shannon's information entropy as a way to understand statistically what's happening inside the repo. Down here, I'm showing another part of this that we can use the JSON.dumpString method to pretty print the data in raw format. This is what it looks like. So it's in JSON format, which means we don't have to use it just inside the Python API. We can send this to other places. Anywhere that's, say, JSON compatible would be able to ingest this as additional data. And scrolling down a little bit further here, this is how it looks when you use this through the command line interface. We just have, I'm adding this exclamation point, which allows you to run command line commands through the Jupyter session. And I was typing on Almanack table, and then I'm sending it the path to the repo that we want to analyze. And we see here that we get that same JSON structure. It's a little bit less pretty here in this format. And then down here, I'm doing the same thing for the Almanack check. And we see that it's telling us that it's running the checks and what version we're running and what it targeted. And then it tells us that we found some things wrong with this. So even for the Almanack, we strive to help apply the same checks to make sure that this is that we're meeting our own metric standards. And right now we don't have a DOI associated with the project. So it's telling us like, hey, you probably want to check this out at some point, that this is an important aspect of scientific software development that you should have. And then it gives us a score down here of 81.82, 9 out of 11. So heading back to the slides here. As far as our Almanack roadmap, we have some plans ahead. We're focusing on building some collaborations to put the Almanack in the hands of people who can benefit or who can help develop it. So we're really interested in folks who want to use this readily or people who want to develop it. It's a completely open source project. So if you're excited to contribute to something like this, please feel free to reach out or begin adding issues and follow the contributing guide. We also would like to continue the efforts around the CLI linter. So we're planning to release the CLI-based linter, which is just released as of this weekend. So that's pretty new. We'd like to further that development with a pre-commit hook that allows you to easily install the CLI-based linter within your project without having to include the Almanack as part of your software environment, and also making it even easier for somebody to avoid potential problems before they commit. Pre-commit hooks will trigger checks before you're able to add a commit to your Git history within a project. Sometimes you can commit it, or you can configure it to also do a pre-push. So like if you wanted to check things before you pushed to your host, you could do that as well with something like this. We'd also like to package up a reusable GitHub action, which can be used as part of CI/CD workflows, making this even more usable and readily able to be added to somebody's continuous integration and continuous deployment workflows to make sure that they're checking their work if they'd like to with our tool. We'd like to come up with a sustainability score, which would involve researching how repository metrics influence sustainability and culminating in a single score that one person can understand. So before when I showed that Almanack score, that was a sort of linting score. We'd like to come up with something that's, say, able to provide an inference and is like a way to build a model surrounding how we understand these metrics and how they influence long-term sustainability for these projects. And then finally, over here at the right side, we'd love to integrate with bioRxiv as a preprint server to make software evaluations that are part of preprints really easy and on-site. So imagine you go to the preprint server for looking at a paper that deals with some software. They publish some software as part of their findings, and that bioRxiv could run the Almanack and maybe show the scores for things up front, so that if you're interested in those scores as part of your review of the article and understanding of the article's contents, that you could have that right there. You don't need to go dig up where the repository is and clone it yourself and do all this other stuff to understand whether it works or not. It's already done for you and available there to help and improve your experience with the science. In terms of the Almanack's relationship to Moss, these are just some ideas, but we're really completely open to the relationship there. I think I've been really interested in the project and trying to help where I can. But namely here, I think the Almanack could really benefit from data gathered by Moss. I think there's a lot of awesome data in a number of different spots, but it's hard to find all of the data in one spot. And when it comes down to relationships, say to papers, like between papers and software, or maybe institutions and the software, that's a lot of difficult work that I think could be well served by a large graph effort like Moss is hopefully providing. And I think that Moss could maybe potentially include data formulated by the Almanack, for example, the sustainability score, but maybe it's not limited to that. I see maybe the Almanack eventually coming across the sustainability score, and that could be an important, say, node attribute of a software node inside of this larger Moss graph. And it could help to inform even further use of Moss directly. So in general, I just want to channel that, like, let's garden to thrive in a better future. Let's strive to make these tools and make these projects happen. If you're interested, feel free to take a look. We're on GitHub under the software gardening org, under the Almanack repo is the primary place where the development is taking place right now. Some quick acknowledgements. These are all the folks who have made direct contributions to the project. I mentioned Greg Way and Will Davidson are the core developers with myself, and then also Faisal Al-Kadumi, Vince Rubinetti, Cameron Matson, and in general the Way Lab at the Department of Biomedical Informatics have all been really indispensable as far as their help in adding and helping to grow this project. Also, a big shout out to the Department of Biomedical Informatics within the School of Medicine at the University of Colorado Anschutz Medical Campus, where I'm housed, and that's enabled this work to occur. The Better Scientific Software, which is the place where I got the fellowship to work on this, which is a great place and has its own very awesome resources. I encourage you to check out their website at bssw.io. And then the Sustainable Horizons Institute, who's been working with the Better Scientific Software group to help enable the fellowship process. So a big thank you to everybody on the screen. Really, really appreciate all of your help in helping this project come to fruition. So also a big thank you to everybody here to listening to me present. Really appreciate your interest, and yeah, I'd be happy to take any questions or comments.
People think of questions, comments, put them in the chat. I'll highlight how much I love the fact that this is just an intuitive tool for researchers. It's meant to be used by people who could just like create software that's used in research and be reminded that, hey, you should probably have a DOI in there, that sort of thing. Boris, go ahead.
Yeah, I have a couple of questions. First, more probably very naive questions, but first, you are really language agnostic, right? So if I have a Python project or R project or Julia project or whatever, a mix of languages, you don't, your software is not really stopped by this, correct?
That's correct. Our focus is to be language agnostic. There are some metrics which dive a bit deeper into the languages specifically. So one, for example, would be we look at test coverage data, which we feel is important to ensuring the sustainability of a software project. And those files and procedures are a bit specific to each language. So for Python right now, that's usually coverage py that's running, and then there's usually a coverage file somewhere that's sometimes coverage.xml, coverage.json, or I forget the other format, but we look at those specifically, but we also try and make those decisions based on what the primary language is that's detected of the repo to begin with. So there's definitely a chance for some shearing when it comes to that. But yeah, in general, our hope is that we can grow these efforts iteratively and help to improve it and increase our own coverage of different languages and how they approach, say, code coverage or other specific aspects that are related to languages.
Thank you. It's very impressive. Thank you. And so my second question is that one of the most important metrics is documentation coverage, how well the project is documented, how much of its functionality, functions, and so on is covered, and so on. And I don't know about any way of systematically calculate this metric. So what do you do for this?
Yeah, it's a great question. And we also feel the same, that it's a really huge part of quality software and ensuring the sustainability of a project. Right now, we're doing some very, I'd say they're simple. They seem simple, but maybe they're not so simple. So I don't mean to downplay them, but we're looking for README files. We're looking for contributing files and code of conduct files, and then also license files as sort of a start towards that documentation, providing a bearing for any particular developer or user of a software to understand a quick summary about what's going on inside the software, but also to understand how they're supposed to contribute and govern a project, or perhaps the boundaries by which they might be able to use it. For a lot of software, especially in the open source ecosystem, say missing a license file is basically a non-starter. It prohibits the use of that software in certain arenas. So we feel that that's really important as sort of a starting point for those things. We've also done a bit of digging into looking for a docs folder where further project documentation is often stored. But I also feel that that differs from language to language and ecosystem to ecosystem. So we might need to refine that a bit further. I think something that came up was thinking about code comments and maybe counting code comments, that they exist at all within the certain files. But that also jumps into, say, more language specific dynamics where we'd have to sort of use a dependency or a technology that can incorporate the grammars for those languages to make sure that we are counting those things and measuring those things effectively. But it is all stuff that we want to do. So if you have any ideas in that space, I'd love to hear.
You may want to look into user guide file, which is identifiable. Also, in some ecosystems, some repositories would not accept a program for me without a man page. Of course, man page might be obsolete in some ecosystem, but some love them. So you probably may want to add some points for having man pages, user guides, and other things like this. And there are some practices in Python, in Perl, in R. There are some practices of standard user guides and vignettes. I agree that it's different from language to language, but there are rules. So one of the ways you might want to do, you may want to look at the repositories like CRAN, CPAN, C10, and look at their guidelines. And they usually are very well formalized and could be converted into formal checker. But again, it was very ambitious. It is very ambitious and very well done project. Congratulations! It's very useful and needed and very well done. Thank you.
Thank you so much, Boris. Really appreciate the feedback, and we'll look into those things.
Dave, I just want to say, yeah, I love it. It's some of the things I've been thinking about looking at the various projects and repos, and look forward to incorporating that into Moss, right? Because I take it we don't quite align in some ways yet.
Yeah, for sure. Yeah, I mean, it'd be interesting to see if we want to incorporate this as part of the project, or how the two projects might intertangle.
I'm curious, what did you mention with the Shannon entropy? How did you use that?
Yeah. So with Shannon entropy, what we did is we used existing research in the domain to gather a metric at both the aggregated level and also the file level. And what it does is it Shannon information entropy is a type of calculation that you can make about the difference between two things, and there's a statistical method that backs it up. That's probably a bit too in depth to go through over this call, but we tried our best to document this within the effort. And really, what it's doing is looking at the diffs between the files and how those change over time, so that if the diffs between the files grow over a certain period, that your entropy would increase quite a bit more. And files that change maybe less, or a software project that has files that change quite a bit less, would have a lower amount of entropy, so a lower amount of change. And we feel that that metric might be important to, say, modeling the sustainability score, that repositories that show, say, a great deal of change over long periods of time are going to be probably pretty hard to understand or hard to maintain because the core developers have maybe flipped too many times, like there's too many changes in personnel, or there's too many different changes that cause even the people who are working on that as core maintainers to not understand how the software functionality and capabilities work anymore. At least this is what the research sort of posits at this point, where a lot of it we don't know what will happen, but we're doing our best to maybe provide the metric up front as a way to further understand the repositories.
That's pretty cool. Yeah, I'm just curious. The Shannon entropy, does it map? Did you do a testing of the metric, for example, with a data set that you know, for example, or how would you map, you know, the Shannon entropy of a set of files, for example, and their changes to actual, you know, a good repo or system or a bad one? Or how would you identify what kind of Shannon entropy would you see in, you know, the worst repo, for example?
Right now, we don't really know what might constitute good or bad. So right now, we're just trying to provide the information entropy calculation up front as just a metric, but we haven't necessarily put that into the checks that are performed by the linter. So not all the metrics that are within that table functionality are included as checks. Only the ones that were fairly certain are associated with sustainability practices or things that have been cited within scholarly research as being indicative of sustainability, are the things that we're using inside the linter today.
Okay. Okay.
I'm
Awesome.
curious,
All right.
Dave. Do you see the Almanack? So one of the things I'm seeing here is that the Almanack collects a lot of the same data points that we're collecting on in Moss. There's a lot of different data points as well. So there's two questions here. One, do you see your vision of the Almanack as a prescriptive thing? It's more of the metric itself versus the data collection aspect of it, where it might run over Moss. If Moss is a giant data set, it would be a system that pulls out the data that it's interested in and turns that into a score, a sustainability score. And the second question is, do you store the data every time someone runs this over one of their projects?
Yeah, thanks for the questions, John. Yeah, so I think for your first question, ideally, the Almanack could pull all of this data from some place where these things have been calculated or measured for any repo. Because right now, what we do is we look at the Git repo, like the files themselves. So it has to be cloned down at the moment to get some metrics that we're not able to get feasibly from pretty much any place else in a cross-platform language agnostic way. So we clone down that repo and we're getting some metrics from there. We're getting some metrics from the ecosystems API, which is really awesome and helpful for leveraging or for gathering this type of data. We're using the Almanack API to try and gather some paper level information. And we're also using the GitHub API today, which is a lot of APIs. And currently, we take only about 6 seconds or so for measuring against the Almanack itself. But for a larger repo, it might take much longer to gather that type of information, depending on how long it takes to query those servers for the information, and then also gather those metrics from the Git repository itself. So ideally, it'd be awesome if we could leverage, say, just a single API to gather all of that information via a query against, say, like the Moss of the future is the way that I look at it. And then your second question, I'm forgetting what that was now. I
Every time
apologize.
someone runs the Almanack or the queries on their project, you store that data.
We do not store any of the data. So every time that the Almanack runs is sort of a unique instance of the report, and we don't gather any sort of metrics or do like a callback to any sort of server to collect that information from users who are implementing the Almanack.
This would be super interesting because this could be a point of integration too. Because every time it's a way to keep Moss updating. Is every time someone runs the Almanack, it just kind of ports the data points to be ingested later. And that also gives us another indicator of how many times are people running this Almanack over a piece of software. And if a lot of people running it over a piece of software a lot, then that's probably an important and interesting repo versus no one's ever run this before. Yeah, I think there's a lot of trust.
It's a great point. Yeah, crowdsourcing the gathering of the metrics as opposed to doing it like in an all at once go. I think it could be really interesting.
Any other thoughts? We've got 5 minutes left or so. Any other questions for Dave? Comments, suggestions, things he's got to read? Great. Then we'll get this up. Do you want this on YouTube? Do you mind, or do you want it shared more privately within the sort of Moss community? We've got a large email list.
Oh, I'd be more than happy for it to be up on YouTube.
Fantastic. So we'll get it up there this week, and folks can go back, and we've got the links in the invite as well. If you want to look at the slides, take a look at the repo itself.
Yeah, if you don't mind, I would like to share the slides and the YouTube video when it's in YouTube with people at CZI who are interested in these sort of things, if you don't mind.
Yeah, of course.
Thank you.
John, should I get you the slides for like an all at once kind of a thing, or how should I share
Yeah.
the slides?
Yeah, if you give it to John and John shares with us, it would be or you can send it to me directly if you don't.
Right now, I've got those 4 links you sent me before. Those are going up on the YouTube. Do you want the slides up there as well?
Sure. Yeah.
Yeah.
Then send me those links, and I'll pass it through where it's got to go.
Yes, this would be very useful. Thank you.
Yep, sounds good.
Fantastic. And happy Monday, all. We'll see you Wednesday. Anyone who wants to come hack on this stuff, maybe we'll try and see what data points y'all are collecting with the Almanack versus what we've already got in that little spreadsheet we put together last week. Do an analysis that way.
Yeah, sounds good. Thank you all so much for listening and attending. Really appreciate it.
Thanks, Dave.